Students, friends, today we'll discuss operational amplifier or op-amp. Operational amplifier. It is in short written as op-amp. Op-amp. What is an op-amp? Amplifier circuit. It is a linear IC. It is linear analog IC integrated circuit. Yesterday we have seen that analog and digital ICs. We are using this analog ICs for this semester in one or two practicals. Let me say about operational amplifier. Fine. So, an operational amplifier is a high gain, direct coupled negative feedback amplifier with high input impedance, low output impedance, with feedback is added to regulate its frequency response. These operational amplifiers are made with different internal configurations in linear ICs. An operational amplifier is so called op-amp. The word operational gives something which does some operations, say mathematical operation. An op-amp is so called operational amplifier. It is designed to perform operations like addition, say subtraction, multiplication, say differentiation, integration, etc. in analog computers. Today, its usage is so wide. The scope of its usage is so wide, and because of its scope, the popular name operational amplifier is continued. The typical uses or typical applications of this operational amplifiers, I will mention one or two in different fields. Scale changer. Scale changer. It is used as scale changing applications. It is used in analog computers. It is used in instruments or instrumentation. It is used in control systems. Great variety of applications we can find even in the laboratory. We can design wide range of oscillators using this. So these are certain applications of this operational amplifier. Operational amplifier IC is a complete operational amplifier circuit. What I means to say, a complete amplifier circuit. We design using this operational amplifier or op-amp connecting externally some resistors, capacitors to change the required changes in the circuit or to change the characteristics of this IC. This operational amplifier IC is available in different packages. So a common IC, linear integrated IC, you can find 2 dozen or more than that, or nearly, say, transistors. That includes NPN as well as PNP, several resistors and few capacitors. So that forms the internal configuration. We are not going to what is called as study the internal block diagram of operational amplifier. Here electronics students who are in second semester, they are studying this in detail. If I go on teaching this and say its importance or its weightage in the question paper is say hardly any, 1 or 2, even sometimes no in that case, but we are using it for practicals. When we are using it for practicals, a student must have little knowledge about this, and therefore I am discussing this topic not in detail, to a required extent, you can say. This operational amplifiers are having, say, different packages. It is dual package or a single package. Even it was available earlier in metal package. Nowadays they are having in plastic molded package. So in India we are using this IC 741, that is with the code CA741 CT or CA741T. Bharat Electronics Limited, BEL, is manufacturing this in India, that is situated in Bangalore. So let us go for the circuit symbol of this IC. Circuit symbol of op-amp. Circuit symbol of op-amp. Say op-amp IC 741, or even symbol for all the types of ICs. Fine. Let us draw this. Let me draw a triangle here, and this is a triangle indicates this here. Symbol, this is pin A here, time being, this is called as V1, and say this is I1. Okay, this is terminal B, let me call this as, it is having V2, say current I2, and it is positive, and say the terminal C here, that is, and here this is plus VCC, will write its, and this is minus VCC. Right. Here we can write this as A, the open loop gain of an amplifier. It is amplifier IC, open loop gain of an amplifier with 2 inputs and the 1 output here. So terminal A and B are the inputs. Terminal A and B are the inputs and terminal C is the output. A and B are inputs and terminal C is output. Here a negative sign is marked. In the symbol, negative sign is marked. The negative sign indicates it is inverting input. Inverting input terminal. Inverting input terminal. What do you mean by inverting input terminal here? Say this is output and this is input. All the inputs are measured or applied with respect to ground. Output is measured with respect to ground. In many books they give this as a symbol. Sometimes they give this, they neglect this. Both will do. So input is an inverting terminal with negative mark, and with a positive mark here it is non-inverting. Positive mark, non-inverting input. Non-inverting input. What do you mean by inverting input here? The output is out of phase with the input by 180 degree, or the phase difference between input and output is 180 degree. Say for example, here is the input. Output at this point will be this. In case of non-inverting terminal. In case of inverting terminal it is. In case of non-inverting, there is no phase difference between input and output. So in non-inverting terminal, input terminal means the phase difference between output and input is either 0 degree or 360 degree. That means whatever input you are applying here, say you are applying the input like this, output will be same as the input. Same as the input. So this is about the symbol. The output voltage sees the output voltage, and here the output voltage is always proportional to the difference of input voltage. VO, suppose this is VO or VO is, this is C, let me write this as VO with respect to ground here, and that is output, and this output is proportional to difference of input A times say V1 difference V2, right? So this is proportional to difference to the inputs. A is the open loop gain. If V1 and V2 are the inputs and VO is the output here, so we can write, say, that is, let me, VO is equal to AV1 minus AV2, or it is A times V1 difference V2, or say minus V2. So V1 and V2 are the inputs and VO is the output. So A is the open loop gain of an amplifier without feedback. For ideal operational amplifier, this gain is infinity. Gain is infinity. So this IC, this is about the symbol 741. The IC 741 called as operational IC, in short op-amp IC. Op-amp IC 741. The point here is why they have given this number 741. There is some meaning, they have some points to keep in mind or to remember its number. Why they are not given some number like this 325, which is 325 is the last 3 digits of my mobile number. Why not they have given some other number? Why only 741? This operational amplifier IC is 8-pin IC. 8 pin IC. Sometimes it is available in 16 pin IC or 14 pin IC. As it is manufactured in India, it is 8 pin or 16 pin IC. So here it is a 8 pin IC. This number indicates there are 7 functional pins. 7 functional pins. 741. This number indicates there are 7 functional pins. This 4 indicates 4 pins are taking or involved input, taking input. And this number indicates there is only one output. One output. Fine. There's only one output. This is why it is depends upon the number. Every IC will have some number, and giving number there will be some particular reason, and for this IC these 3 points to be remembered. So let's go for the pin out of this IC. Pin out diagram of IC 74. Let me write pin out, say of IC 741, say op-amp. And the pins This is important as far as our practical is concerned. Let me draw this figure here. Okay, I'll draw this figure. Fine. This way. Okay, this is. Let me take this as a little bit at the center. This is to identify which pin number is 1. So I will mark it here like pin 1. Say this is 4 on this side. Pin 2. Pin number 1, pin number 2, say pin number 3 here, and say here pin number 4. Okay, so on this side pin number 8, on this side it is pin number 7, they are parallel, 7 almost. This is pin number, say 6, and okay, pin number 5. I will draw here a triangle showing its symbol. Like this. Let me draw it a little different way. Okay. So this is connected to this, it is negative. This is connected to this, it is positive. It is written here A. This goes to pin number 6. Right. This goes to pin number, say 7 here. Okay. This goes to pin number 4. And so pin number 5 and 1. I'll write here offset. and this is negative offset. Pin number inverting input. Pin number 3, non-inverting input. This is negative of VCC, pin number 4. Say this is offset, that is positive. Say pin, this is output, this is positive VCC, and this is no connection, NC, no connection. Okay, this is IC 741. This is pinout or fill configuration of IC 741. Let us look at the functions of each pin here. Let me take pin number 4 and 7. Pin number, say first pin number 4, pin 4 and 7. So this pin number 4 and 7, this and this one. For this IC called as 741, it required, to bias this IC, it required dual power supply. Say I will write PS. What do you mean by dual power supply? So far you have not used. Say it is having plus 15 volt with respect to ground, that is 0 volt, and then minus 15 volt. With respect to this, it is plus 15, that is common here. With respect to this, it is minus 15, and this is called as dual power supply. So we need this dual power supply, and the variation or magnitude of dual power supply should be 5 volt to say 18 volt. We apply it to 15, plus 15, 0, minus 15, plus 15, 0, minus 15. Normally we call it as plus or minus 15 volt power supply or a dual power supply. There is a split in the output of the power supply with respect to this. This is a common point. Now, positive of dual power supply is connected to pin number 7, and the negative of power supply is connected to pin number 4, that is pin 4 and 7. This is involved in the input. Pin number 1 and pin number 2, say pin number 2, pin 2, that is inverting input. Pin number 3 is non-inverting input. It is input with respect to ground, that is this point. Input with respect to ground, that is this, that is non-inverting pin. Pin number 4, pin number 3, pin number say 2. 6 is the output. Pin number 6 is the output. Output is always measured with respect to ground, the common point, that is this. So pin number 6 is the output. Pin number 1 and 5, the having common thing, pin number 1 and 5, called as offset. See, this IC 7400, it gives the output without any input. That is a very interesting thing. It gives output without any input. Say, if you bias this IC, if you put this supply, dual power supply connecting positive terminal of the power supply to the pin number 7 and negative to the 4 and if you measure the output, it shows the output on the CR. You can see this is DC level, the pulse, rectangular pulse with respect to ground. That means without giving any input are floating or not connected, it gives the output. Sometimes we don't want this. So magnitude may be in millivolt. or it may be little more. However, the magnet is small, it is having output. For this, what we do is we adjust the offset, we call it as offset. Say this pin number 1 is connected to the say potentiometer, and pin number say 5 is connected here. Okay, pin number 5, or you can say this way also, and a variable. This is 4. Right. So adjust this port for offset where the output is VO is equal to 0 volt. Right. Because we are using this IC for mathematical operations. Say I want to add 2 inputs. Say I have given for one input 2 volt and for the other input say DC 3 volt. If it is gives 5 volt, which is wrong. For having arithmetic operations like addition, subtraction, multiplication, integration, differentiation, we have to go for this offset. For other circuits that makes no difference, still we have to adjust it, and they are called as offset, pin number 1 and 5. Hope you got this. Pin number 8 is, in fact it is extra pin, it's a dummy pin. There is no connection for the internal circuit from this pin. Since we want to place this IC in the circuit or on a printed circuit board or in the circuit, either on the breadboard, a socket must be there. So 8-pin socket will be there, and then slots will be there. You can insert this IC in instruments, or even on the breadboard you can fix it. So this is a dummy pin, which is here NC means no connection. NC means no connection. Well, in addition to this, we have certain ideal characteristics of this. This often, what are its ideal characteristics? If any IC is slightly behaving away from the ideal characteristics, we call it as practical. Okay, so let us go for the characteristics of ideal operational amplifier. Characteristics of an ideal op-amp. The characteristics of an ideal op-amp. Fine. This ideal operational amplifier has several characteristics. Let me go one by one. See this, its input impedance, infinite input impedance, its input impedance is infinite. Either you can write Zi or Ri, it is infinity, because it works for both AC and DC. Second characteristics, it is having very high input impedance, that is almost infinity for in ideal case. Zero output impedance. Zero output impedance, RO is equal to 0. For ideal operational amplifier, the open loop gain, that is A is equal to infinity. Open loop gain is infinity. That means, like, say here I am recording there is a video recorder, and above my head a ceiling fan is rotating. The ceiling fan here is making some sound. That means even a small change, a wind blown by the fan gets recorded. You can listen to it. Yes, here similarly, a small feeble differential input gets amplified at the output. And therefore we say the open loop gain is infinite. For a practical IC, that is practical op-amp, open loop gain is very high. Perfect balance. This is perfect balance. We can balance, that is using offsets. You can say VO will be equal to 0 provided V1 is equal to V2. We have both inputs as inverting and non-inverting. Many application we can study DC, using DC as well as AC. Therefore, if V1 is equal to V2, the magnitude of input, that is at inverting input, that is at non-inverting input, if they are equal, output will be 0, and that is called as perfect balance characteristics. Say fifth, we'll go for bandwidth. See, this is amplifier IC. It is operational amplifier or amplifier IC. Bandwidth of this operational amplifier, for ideal operational amplifier, it is infinite. When we are using, it is a practical IC, we introduce a resistance called as feedback resistor, and to some extent we can reduce that gain. Bandwidth for ideal operational amplifier is infinite. Sixth, what is called as zero drift. That means characteristics do not deviate, right, when there is change in the temperature. Zero drift. No change or no change in the characteristics with temperature. No change in the characteristics with the temperature is called as zero drift. I have another characteristics, what is called as common mode rejection ratio. It is called as CM.